Convolutions, very, very important. Very, very important. So, so we have learned this already before. Oh, then,
We are sharp about
it,
it.
then it makes my work so easy, right? So,
Especially video.
oh, then that makes my work very easy. When you use something like this is what is called the DNA, dense neural network. When you draw something like with the neurons and stuff like this, and then here what you are learning is what the weights and then the biases. That's what you are learning normally, right? Now this is a very simple image. This image, there's not much happening in the. If you take the MNIST data set, it's just a grayscale image with the number. It's always based. Everything is dark with the number in the middle. That's all it does, right? This is a very simple image. Now, if you take a very complex image, like you take a colored image with some background and a lot of things happening, this will fail miserably. This dense neural network, using the dense neural network, will fail miserably, right? So now, what do you normally do? So what you normally do is that you use. So instead of using the dense neural network, what we do is we use what is known as another layer called the convolutional neural network, CNN. Eh? I started it though. It's recorded. Right? So when you have very, very complex images, like with background, colors, whatever, what you have to use is convolutional neural network. And then why do you use that? You guys know what filters are, right? Now, if you like in normal, in kind of normal images that you take, so some of you will use a filter to look more at the. Aha. So it depends. We have a lot of filters, and then filters do different things. Probably somebody would like to remove the background from your image. So you click something, that thing you are clicking is the filter. So you click it and then it removes the background. Some would like to enhance the whatever, make the image darker. Then you use a filter, right? So now that same idea is used in the machine learning, right? So what you do is that I have an image. Right? The image is probably is a human being, right? Very, very important. It's a human being, right? Now, if I feed this image through the dense network, right, it might work, it might not work. So I can have an idea to say that, okay, what if I feed portions of the image? So I know that this is a human, but what makes a human human? The human has a head, right? He has hands, he has legs, right? So what do I do? So I design filters that will remove everything and then have only the head there, right? So I have a filter. One filter will only identify the head, so it will remove everything and then it leaves only the head. So I have this one and I have only the head, right? I can define another filter that will take only the hands. So another filter will take only the hands. It's like this, right? Then I take only the legs. Again, something like this, right? And then now instead of feeding this entire image to the network, I feed it with this, the legs, the hands, then the face, and then I say that this is a human, right? So now it means that every human has hands, face, right? So it means that so once I pick only the head, I'm using one filter. There's a filter that can pick only hairs, right? So I use one filter, I use another filter here, and use another filter to get the hand, so that's what we do in convolutional neural network. So what you are doing is that you are doing feature extraction. Once you use your filters to extract these hairs, hands, and stuff like that, it's known as feature extraction. You've extracted some features from the image, and then those are the features you use to feed into your network. Understood? Right. So how does the filter works. So now the filter works with convolutions. So if I take an image like this, if I take, let's say I have an image, a very small, if I take an image like this is a 3 by 3 matrix, right? 3 by 3 matrix. Then I have a filter. This is the convolution sign, right? You guys have done it already, probably. This guy said you guys have done it already. And then we take a filter. This is the image. We call this the image. And then we have the filter. Probably 0, 1, 1, 0, something like this. So what do you do in convolution? You take this one and then you convolve it over the image. So you take this 2 by 2 and come here. So this convolve with this one. Then we have a metric known as the stride. Because I'm passing, it's like we're passing this filter over the entire image, right? So you need something called a stride, the horizontal stride, the vertical stride. So how many steps am I moving? So if I come here, if this is my first one, right? I take this one and then I do it like this. My next one can be here, right? So I say that the stride is 1. I just move 1. Are you seeing it? Now after, then you do this, so you take this portion of the image, convolve it with a filter. Take this portion of the image, convolve it with a filter. Then once you get to the last end, you come down, take this portion and convolve it with this, and then take this portion also, and convolve it with this. So it means that if I take a 3 by 3 matrix and then with a 2 by 2 filter, right? And then I can actually predict what the output will be, the size of the output. The output will be a 2 by 2, right? Because we took this one, and then very important, if the stride is 1, and I take a 3 by 3, I take a 2 by 2, and then I slide this one over this with a stride of 1, the output will be a 2 by 2. Because we have, this is 1, this is 2, and then this one will give me, this one convolve with this one will give me one value, right? Because you guys know what convolution is. So if I take this one, it's 1, 2, what? 4, 5. Then with 0, 1, what? 1, 0. So convolution is just this times this, plus this times this, plus this times this, plus this times this. Will give me one value. Then the next one will be this one. That one will give me one value. Right? So it means that all I've done is if I have 3 by 3, if I have a 3 by 3 kind of matrix, 3 by 3 input matrix, right? And then I have a 2 by 2 filter, right? My output will be 3 minus 2 plus 1. And then 3 minus 2 plus 1. So it will be a what? 2 by 2. So you take this value here minus this value here plus 1. The height minus the height of the filter plus 1 will give you the dimension. Very, very important, right? You do understand? Try, try to continue. So that is the whole point of convolution. So that's how convolutions are done. So you take some images like this. This is a very complex image, and then you can use dense network. So what we're using is you have to use convolutions, right? And then this is the standard. So this is just one channel convolution. So what we did here is just one channel, right? One channel means that it's just a 2D image like this. Just 2D. Like if you take a grayscale image, the black and white images has only one channel. It has only the grayscale. So you know that in images we have something called the RGB. You guys have heard it before? RGB. Yeah. Green means what?
I don't know, but I know yes. RGB.
Red, green, blue. I mean, so we said that images are just numbers. So if you take an image like this, we said that it's made up of pixels, right? The pixels are just are numbers. So the numbers ranges between 0 to 255, right? So now if we take a grayscale image, like a black and white image, right? There are the red component has a value, the G component has a value, and then the B component has a value. If we take a grayscale image, the R is equals to the G and is equals to the B. It's the same, it's just one value, right? Understood? R is equals to G is equals to B. So red is equals to green is equals to blue. That's what black and white images are. If we take colored images, on the other hand, the colored images have
So hold on.
what?
We're taking notes.
And I said for grayscale, the images, for grayscale images, the R is equal to the G is equal to the B. The R value, so as I said, the value ranges between, so the R value will range between 0 and 5, the G value will range between 0 and 255, the B value will range between 0 and 255. These are all different values. But if you take a grayscale image, the R is equal to G and is equal to B. If we take colored image on the other hand, you have to use the R has a value, the G has a value, the B has a value. So we say that the colored images have three channels, right? It has the R channel, the G channel, and then the B channel. So if I draw an image like this, it's just a grayscale image. If I want to draw a colored image, it will be like this. Understood? So we have the width and then the height. It is all the same, width and height. And then we have the channel, right? But in grayscale images, we only have the width and then the height. There's no channel, it's just one channel. And so that is how images are. So if you take a colored image has RGB. So that's how you draw it, something like this. This is for RGB. Understood? So it's just something like this. And then you can,
So sir, black and white, they are all the same.
yeah, the R component is the same as
So the color,
they're completely different values, right? So I've explained this, I've explained, so the filter is also called a kernel. Understand that? I've explained, so this is how convolution work, and this the calculation to find just one. So as I said, there are different type of filters. So if I take a filter like this, a filter like a 3 by 3 filter, the first one, negative 1, 0, 1, negative 2, 0, 2, negative 1, 0, 1. And then I apply this filter to this image. So it means that I convolve this 3 by 3 to this entire image, right? What this filter is doing is that it is actually blackening everything in the image, but enhancing the vertical line. So you can see that once I apply this filter to this image, only the vertical lines are visible. Have you seen it? That's what filters do. They enhance some part of the image while they blacken out other parts. So this filter tool is used to get the horizontal lines. So that's what filters are. Now, so now the whole point is now after you have done your convolution, right? You've gotten your convolved image. That's how you call it. You call it you've gotten your convolved image. Sometimes the image, the number of pixels, they are always too many. So you have to reduce it. Are you understanding? So let's say I convolve my image and then I get an image with a size of 10 by 10. So I get an image that looks like this, and then it's 10 by 10. So once you do that, right, sometimes you want to actually reduce the image size. So what you do is that you use what is known as pooling in machine learning. You use pooling. So if I say, and then we have different types of pooling. We have one called the max pooling, right? So what the max pooling does is that it will reduce the image by a dimension. So if I say max pool by two, max pool by two by two, right? So it will go into the image and take this portion of the image, the two by two portion of the image, right? And then it will look for the highest value and pick only that one. So it will form a completely different image with this one. So you take this one, pick the highest one, and place it here. Take now, move again, and take another two by two, and then place it here. So it means that in the end, your image will be shortened, right? So it means that out of one, two, three, four pixels, it has picked only one, right? So if you have a two by two max pooling, and then you have a 10 by 10 image, by the end of your max pooling, your image will be 5 by 5. It means that you reduce the image by two. So all you do is once you see the two by two, you just take this two and divide it by this one, and then that will be the size. It marks fully. Understood?
So basically, it has half the
It has half the image. Understood?
yes, yes.
But now you see the max pooling.
Yeah, yeah,
You
yeah.
see, when you look at the pattern, I was just looking at the pattern. I saw that they picked the first one they picked the highest value. The second one was the highest value. The
Yeah.
third one wasn't the highest value. It was the highest value. The third one was the highest value.
255 is the highest value.
So they picked the highest value among
Maximum
the
pool. So that's why they name max pooling. So maximum. It picks the max. And then they are different from some. One of them is also average pooling. So what it does is that it picks those four pixels and then it adds them and divide by four.
Four.
That's what it does. But we don't usually use that. We usually use the max pooling. Right? So I think I've explained this already. So if you take something like this, the human has hands, like I've already explained this. Right? So all you are doing is that you use your filters to extract the hands, all of that, and then you feed the network with this, with a filtered image, and then again you make a guess, and then so now here, instead of learning the weight and biases, you are learning the filters. Right? Those two by two filters or whatever, or three by three filters is what the machine is learning, not the weight anymore. So here there are no weights, they are filters. Understood? So you make a guess, you measure the accuracy. So it means that making the guess means that you are guessing the filters instead of the weight and the biasing. Now it's a filters. You make a guess of the filters, you measure accuracy, and then you optimize. Then you go back again and repeat, and then you are done. So this is an entire architecture of a CNN, a convolutional neural networks. So you have the input image here. So if you take the MNIST data set, it's a 28 by 28 image, right? So you have the input image here. Then you have your filters. So this is a 5 by 5 filters, and then there are 8 of them. So that's why you see 5 by 5 by 8. Right? And then after you convolve, so you take each filter will be used to convolve or will be passed through the image, and then you'll get a completely different image. So if you have 8 filters, you're going to get 8 different images. That's what it means. So that's why here you get 28 by 8, then by 8. So it means that each filter generates a completely different image. And then you have the radio, you can use the radio again here. Then you have the max pooling here. So if you have a 2 by 2 max pooling, you know that the size is 20 by 28. Then you will reduce by half. So you have 2 by 2 by 8. Then this, after you are done with all of this, right? You are still doing, you must remember that you are still doing classification. So you now need what is known as the fully connected layer. The fully connected layer is just like the dense layer. It's the same as the dense layer. Those neurons. So after you've gone through the convolution and then the max pooling, you need to pass that max pool data through a fully connected layer. The fully connected layer is just like the dense layer, as I said. It's just those neurons, right? So first of all, you have to flatten your image. We have already looked at that. You flatten your image, then you define some kind of neurons to it, then pass it through the neurons, and then your last layer is about 10 neurons, always 10 neurons, if you are doing MNIST data set, 10 neurons, and then you pass the image through that those 10 neurons, and then you get your value. And so this is the architecture of the CNN, the convolutional neural network. Right? So what is the time? Oh, then we can do some the one how I'm going to show you how the question on this one is going to look like. So to do that, we need to classify. So now, so now, you know that we at first we're always using the what? The MNIST data set, right? And then we said the MNIST is 28 by 28 pixels, and then it was numbers. Now we have another one called the CIFAR 10 data set. The CIFAR 10 data set has also 10 classes. And then the class 0 are airplanes. So the images in the class 0 are only airplanes, so different forms of airplanes and stuff like that. The images in class 1 is automobile, like vehicles and stuff like that. The last one is trucks. So we have 10 of them. And then these are colored images, and then this is, I think, 32 by 32. So they are 32 by 32. 32 by 32. Understood? So let's see how to classify them, and then that's where one of the questions, and then that is one of, and then that is the biggest, or that is the question that has the highest mark saved. So you have to pay attention. Uh, no internet here, right? Is there internet here?
Oh, you can join the show.
Which one? I wanted to use the collab. This one will take some time.
What's the name? Please, can you see any phone or something? So you can join the show.
I'm coming.
So AI did the this year was showing and showed the
You get the concept more. You have the application, you have the physical level, physical level. This is behind you. God be the glory.
Three weeks more.
No, it's 4 weeks. 3 weeks. Yeah. Starting 23. And then the last year of the month. What is it now? Last 3 weeks. That means you don't get it. Yeah, that's it. That's great. We do that one before the master. The week is ending on Sunday. So Monday is Sunday. Then you have 4 weeks. How do you say you have 3? 2 weeks. So the last 6 weeks. Sunday. After we have
There's
decided
anyone
on
on that?
so this is the third graduation. So we are
Okay, so this is the this is the notebook for classifying the CIFAR 10 data set. Classifying the CIFAR 10 data set. So I won't go through it. So you can go home and go and run all of this. You can just run them and then you see how it works. But the most important thing is I want to show you is here. Okay, yeah, this. So this is the model itself. Like how in the dense layer we define a sequential model, then we kept layers. Then we kept in layers, right? It's the same thing for the CIFAR. It's the same thing for the convolutional neural networks also, right? So here I have some layers, just like the same thing. Model was add, and then I add a layer. So I define it conv2D. That means that is the convolutional layer, right? So if I do conv2D, I need to define the number of filters there. So that's why you see filters is equal to what? 32. So it means that I have this is very important. So I have 32 filters. 32 filters. And then each filter, the filters are also called kernel. So each filter or the kernel size is what? 3 by 3. So it's 3 by 3 filter. And then there are 32 of this 3 by 3. So pay attention. And then I have the activation pattern is rainbow, and then the input shape is 32 by 3. You understand why that is? I said the cipher is 32 by 32. And then the 3 is the channel, red, green, blue channel. So 32 by 32 by 3. Right? After I've done that, then I have what is known as the max pooling. So I do model max pool 2 by 2, I do a 2 by 2 max pool. Then I have another convolutional layer again, conv2D again. But here, the filters are 64. Even though I didn't write filters or stuff like that. So when you see the 64 there, means that we have 64 filters. And then those filters are what? 3 by 3. Right? And then the next one is add another max pool, another 2D max pool. The next is the flatten layer. So I flatten
So
it.
the mask release it.
Yeah, once you see max pool without any value inside, it's a 2 by 2 max pooling. So that's how it works. Then after that, I come and flatten it here. Follow the pattern. Then the next is a dense layer, and the normal dense layer, and then we have 64 neurons. Have you seen it? Dense layer, 64 neurons. The activation pattern is very low, and then the last layer is another dense layer, which is 10. 10 of them, because we are classifying 10 types of images. And then that one, the activation function is softmax. So here, this is what I'm going to do. I'll give you this network, and then I tell you that how did I even say it? So I'll give you the network, and then I tell you that what is the output shape of the first convolutional layer, the first 2D layer. What is the output shape? Then I tell you how many parameters are there. So as I said, the parameters are the filters. So here, the first one is the first output. So pay attention here. The output size is 30 by 30 by 32. Do you understand why?
No.
Yeah? So just like how or what I just like what I taught you with the 3 by 3 matrix, and then the 3 by 3 matrix, and then the 2 by 2 filter, right? What 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 did I say? How to get the dimension? How what does?
3 minus 2 plus 1.
Uh-huh. So now take that same idea here. Now let's go here. How many the what is the size of the filter?
The size is 3 by 3.
3
By three.
3 by 3 filter. What is the size of the image? 32 by 32. So what is the output shape?
I will be 32 minus minus 3.
Plus
Plus
one.
2.
Plus 1.
So what is it?
30.
30 by 30. So that you see, calculate it. Yeah, remember this one. 30 by 30. But there are there are 32. So I said each if you take each filter, right, generates a completely different image. Then there are 32 filters, right? So it should be 30 by 30 by 32. That will be the output shape. So you see how easy that is.
Sir, the, the formula,
Yeah.
32 minus 2 plus 1.
Minus 2.
So minus 3 plus 1. This, if you apply board mass, it will give you zero.
What mass here? How?
No, the same thing.
It's the same thing.
So addition first. So you come and add
When
one.
when we add this people,
Add what?
get 2.
It's
No, no,
32
it's
minus 3 plus 1.
minus
Okay,
minus
okay. Plus 1 is 2.
So
Elder.
it's not plus 3.
Unless you have multiplication.
So we are clear there, right?
Yes, sir.
Now let's take here. What is the number of parameters in the first layer?
896.
So how did I get 896?
Multiply 1 by
30
Eh?
30 times 30.
30 times.
So do and see whether you get it.
No,
You,
you will not get it.
how do you know you get it?
You get 9.
Oh, 3 times 3 is 9.
So
So
that's 900.
900.
So so what I said, here the parameters are the filters. What it is learning here are the filters. So I have my filter size is what? 3 by 3 filters, right? I have 32 of them. This 3 by 3 filters, I have 32 of them, right? Now my image is also 32 by 32, and then I have the channel is 3, right? So what happens is that each of this 32 by 32, right, will be multiplied by the channels. So if there are 3 channels here, you will multiply this one by 1 channel, multiply another of this one, a completely different form of this one by this one, a completely different form of this one by this one. Understood? So it means that I will take 3 by 3 by 32, right? Then by 3. Do you understand?
Second again.
So I said the image the image size is 32 by 32
32, yes, sir.
with 3 channels.
3 channels.
My filter size is 3 by 3. There are 32 of them.
32.
But when I'm doing anything with 3 channels,
Okay, I understand.
Oh no, we don't. Some of us don't understand. Please
No, no,
continue.
no. Yes, of course, but let's say
Step,
I
continue.
get it.
So let's go.
so and then we are not even done yet. So
Okay.
so if I take my filter is 3 by 3 by 32.
Okay.
Then if I'm doing anything with the input size is 3 by 3 by 32 by 32 by 3, it means that I will take this 32, 3 by 3 by 32 and convolve it with the first one and take another different forms of this one, convolve it with the second one, another different and convolve it with the third one. So it means that I'll have my formula will be this 3 by 3 times 32. That's just one, right? So 3 by 3 times 32. Then times this 3, the number of channels.
Okay.
Okay, then plus we have biases also. So and then the biases are always the number of filters plus 32. So if you do this calculation,
Yeah, you get
exactly what.
36.
So it's confusing, but it's also easy once you understand what is happening. So this is just what I'm going to do. guess what is going to be happening. Understood?
Yes,
Yes,
sir.
sir.
So you mean in the
Yeah,
exams
I'll just say,
you
give
ask us
me.
to explain the filters
No, no, I'll just give you this code and say, what is the output shape of the first from 2D? You have to give me 30 by 9, 30 by 30 by 32, and then I will say, what is the number of parameters? And then you have to give me a number. But I'm not saying it's this exact code. That's what I'm saying, but a similar
So
one.
can you use as an example too?
So I'm using this one as an example. But it's basically, once you know the calculation, there's nothing to it again. You can do anything you want.
we,
So,
we like things you know similar
so the next one is, what is the output shape? What is the output shape of the Max 2D, the first Max 2D? What will be the output shape? How will you calculate it?
Yeah, so that was 64.
No, we are talking about here.
Yeah, 32 divided by 2.
Max 2D. How will you calculate that? Hmm?
2 by 2 times 32.
Uh, the Max 2D, as I said, reduces the size of the convolved image, not the image itself. So it means that if you get
The first
the,
one round.
the most important the most important thing about this thing is that if you get there are about nine questions here. If you get the first one wrong, everything is wrong. If you get the first dimension wrong, it's wrong. That's the basic thing. Once you get the first one wrong, all your answers are wrong completely. So you have to pay attention. You have to be very careful. So the max pooling takes the convolved image. So now this output shape is the shape of the output. So it's 30 by 30. So you just divide 30 by 30 by 2. So you get 15 by 15. Yeah, take 2 of them. So that is the output shape. You see how easy that is. But if you get the first one wrong, it means that your everything is zero.
That's 0.
Right? So now another one. The next one is what? Another convolutional layer here. What is the output shape? So you must remember that this output shapes are output of one layer, and then that will fit into the next layer. That's what you must understand. This output shape fits into the mass pooling layer. This mass pooling output shape fits into the next layer. So once you are looking at it, you must be looking at, don't look at the input image again. You're looking at this ones. So if I say what is the output shape of the next, so is the first one is the contour D, we do mass pooling. Another contour D, but we are not taking that input image. We are taking their continuum. It goes from step to step. So now this is taking this shape, 15 by 15 by 52, right? So now what is the output shape? 30 by 30. Why? It's 15 minus, and then you see that that one too is 3 by 3. So 15 minus 3 plus 1. And then this one, yeah, the same exactly. The 15 minus the 3. So here we define it again that our kernels are 3 by 3. 15 minus 3 plus 1 again. And then I said that, and then uh, the number of filters will determine the number of images I get. So it will take by 15 by 64 because we have 64 filters there. Have you seen it? So you see how easy that is. Now the issue now comes in. What is the number of parameters? How do you calculate that one? The same. So like try it and see.
Okay.
so sir are we supposed to show working like this one
If you want, I don't really care.
okay why do we show working we don't care
Eh?
some of us we are sharks we can just memorize
No,
it
no, you can't because
oh we can memorize it
because and I'll give you one question and give you a whole sheet for you to answer. So if you don't feel anything, you just write the answer. It means that you just copy it from somebody.
No, no, no. We will do that rough work at the back.
No, no, no. Just do the rough work in the sheet. So I said I'll just give you one question and one whole sheet to answer. And then the answer is just one line, right? But you show some kind of working and then you just come and write your answer. That's how it is.
And our last lecture, we have to revise some of the key
Oh
areas.
yeah. If not zero, because as I said, once you oh but it's
Oh,
true.
yeah,
You
it's
see,
true.
it's very very easy. But once
Yeah,
you
we
miss,
understand it.
but what
Sir,
once you miss one step, it's zero. This
the
one, they
other
just
one, the second this one. Are we going to use three channel, right?
which one? No, no, no. You are so that one is one. That one. We are looking at this one.
Now,
We want the parameter. Now they had the 18496.
And so that's what we are
That's what
doing.
we are calculating. Say one second, one second.
So this one is either you get like 98 or 100% or zero. All the questions are just calculations. So
the value I'm getting.
what have you had?
I have 1,790. This one from this one. That's what I was asking. No, this one you multiply by three channel.
So now here the channel has changed to 64.
By the it's three by three. It's three
It's
by
no
three.
longer it's no longer 3 by 3. So it's 13 by 13 by 64 image. Have you had it? 13 by 13 by what? 64 here. And then the kernel is 3 by 3 by what? 3 by 3 by 64. So here it has changed to 64. So 3 by 3 by 64 times 64 plus 64. If it's wrong, then you will have to go and do it yourself.
That's what I was asking the channel because I see that the other one channel is here, but this one the channel is like
So what's the answer?
from here.
No, I mean
Different.
do this one. Let me see.
Sir, so yeah,
This one
this one
I
is
think
giving
I had
36,922.
690.
692. How?
It's giving more.
It's even more.
Calculator.
Hey, boy, what do you get?
Charlie 40 something thousand. Now
I
I did
bet
36,000.
36. You get 36.
Yeah, you have to say it.
36, 98.
How do you divide it by two?
Then you get it as a now you need subjectives.
So I think this topic we have to revisit it. This particular slide we have to revisit it.
Which one?
This slide, this page. Don't worry. Our next meeting, we'll do that.
No, I think you said the questions are two. So
Question 9.
nine questions.
9 questions from you.
No, you said there's another one that you will go through with us.
Which one?
If you don't get a 7, look like I said, you will not make yourself proud.
Oh
So
no,
you
we
have
have
to
to
make them proud. You know it's a new course that they are doing.
You
So you
will
can't,
make
you
you
can't. Say has been very consistent. Every day doing videos for us. Oh, we can't do this.
proud. You said.
We can't do
Oh, Woody. Oh,
ourselves like this.
the image is 15 by 15 by 32.
Yeah.
We are using.
We are using the previous.
This one fits into this. So
If you use use that one.
So here
The
is
max two parameters for
yeah. So
the max two.
And that place is 64.
where this place.
Yeah.
Yeah, this place is so the is 64 by 3. Right? So this place is 64 plus 64. So I think that will be the answer. What did you get?
Say,
It's exactly that number, right?
yeah.
So you use the that one to actually do your calculations. Yeah, so you are using this one to do the calculation for this. Then so you that your next one is you are doing max pooling and the next one is max pool 2D. So you are dividing this one by two. And then it's integers. So it will be 6. Have you seen it? So divide this by 2. You get what? 6 point something. But because you are doing integers, it's just 6.
Okay. Okay.
6. So the next one is so this and then now you flatten your next one is your flatten layer here, right? So the flatten layer is here. So what is the dimension of the flatten layer? I said you take your 6 by 6 by 64, and then what do you get? You get 2 3 something. So now the next important thing is
230.
so your next one is a dense layer. So as I said, I think we did a calculation for the dense layer last week or last 2 weeks. So your next is your dense layer. Your dense layer has what 64 neurons. So we have 64 neurons, and then so now here with the dense layer, you are calculating your weight and biases. So how do you do that? So you use this one to get this.
Secondly,
This you are flattening something like this. You are flattening it, and then you get what 304. Now you feed this one into your dense layer. Your dense layer is from neurons 0 to 63, right? 63 of them. So you feed this one to it, right? So it means that I'm looking for the weight and biases here. I said each neuron has one bias. That one is one bias, one bias. So there are 64 biases. So plus what? This is 2304 times how many of this? 64. So it will be 20 and this 10 plus that.
You get 14752.
You see exactly that number, right? And then your next one, then your last one,
say hold on my books. No, so you got 1.7520.
yeah, that's it.
That's what I said. How do you become more than 2304? The flattening.
And so I said you take
You multiply 64.
Okay.
a 6 by 6 by 64. Understood? So your last one is what? Your last one, you can see that we have another dense layer,
It's 10.
which is 10. So it means that we have 10 neurons, right? 10 neurons here. And then your input to those 10 neurons is what? So is this layer, which is 64 of them. So as easy as that. So 64 times what?
10.
10 plus the number of bias. Each neuron has one bias.
Bias. So
Plus what?
10.
10. You get what? 650.
50.
And then I just ask you what is the total number of parameters. So the last thing is the total number of parameters. You add this. And then you get your total number of parameters.
How about the
Yeah, you add the parameters. So I'll ask you all of this, and then the down, what is the total number of parameters? So all the calculations with this, you just add the total, and then you are done.
So
Then
how
you,
about the
it's, the, it's the same now. It's the same as the total number, but that one will not. It doesn't really matter. Understood? So we are done. Any question?